Hey everyone, we're all interacting with AI more and more these days, right? But how often do you get an answer and just pause for a second and think, wait a minute, can I actually trust this? Today, we're going to dig into exactly that. We're moving beyond just getting any answer from AI and figuring out how to build systems that actually prove where their information comes from, making them verifiable, not just invented. And this, right here, is the core challenge. When you're building a system with retrieval augmented generation, RAG, the whole point is to anchor the AI to your specific data, to stop it from just making things up. But then, how do you prove that it's working? How do you give your users the confidence to actually trust the output? And maybe even give them the tools to verify it for themselves? Okay, just look at this slide. It shows the difference perfectly. On the left, you've got this vague, non-committal answer. Refunds might be possible. It's the kind of thing that just makes you lose trust. But then, look at the right. Now that is a grounded answer. It's precise, it's confident, and most importantly, see those little numbers in brackets? It's telling you exactly where it got its information from. That is the gold standard we're shooting for. So this really brings us to the central problem with RAG. The entire point is to chain a large language model to a set of facts. When that chain breaks, the model hallucinates. But when it holds strong, that's when it produces these grounded, verifiable answers. So let's put a name to this idea, groundedness. It sounds a little technical, but it's a really simple and powerful concept. All it means is that the AI has to base its answer exclusively on the documents you give it. It's not allowed to dip into its own pre-existing knowledge. You can think of it like a diligent research assistant. It can still write a beautiful sentence, but every single fact has to be 100% traceable back to the source material. So, how do we prove an answer is grounded? With citations, of course. But, not all citations are created equal. Let's break down the three main formats you can use to build that trust with your users. The most user-friendly format is probably inline citations, which we've already seen. Just like a footnote in a research paper, these little numbers directly link a specific claim back to a specific source document. It's intuitive, it's clean, and it makes checking the facts an absolute breeze for the user. Now, this next one is really interesting because of its precision. Quote spans take it a step further. Instead of just pointing to a document, the system identifies and shows you the exact sentence or phrase from the source. This gives you the highest possible level of faithfulness, leaving absolutely no room for misinterpretation. And finally, we have structured citations, usually in a format like JSON. Now, this one isn't really designed for a person to read, it's for the machines. It's a developer's best friend when it comes to automation. With this, you can build systems that programmatically check sources, track confidence scores, and create feedback loops to make the AI better over time. It's really the engine that powers a robust and verifiable AI application. Okay. So we know what a good, cited answer looks like, but how do we actually get the language model to produce it? Let's dive into how to implement this. It really boils down to a sort of three-step dance. First, you have to prepare the context. Before you even show the documents to the LLM, you label them with these markers, like 1, 2, and so on. Second, you have to give the model a very, very strict set of instructions. And third, after the model gives you an answer, you have to write code to pull out those citations and make sure they're actually valid. And I've got to say, that second step, the prompt, is the most critical piece of this entire puzzle. You have to be incredibly explicit. Phrases like, answer only from the provided context, and do not use external knowledge. Those aren't just suggestions, they are guardrails. They constrain the model and force it to stick to the facts that you've provided. But building the system is only half the battle. Just because you told the model to be grounded doesn't guarantee it always will be. You have to continuously check its work. You know the saying, trust but verify. And that brings up the obvious question, right? You can't manually check every single answer your system produces, especially not at scale. So how can you automate this verification process? How do you turn this kind of abstract idea of faithfulness into a number you can actually track? Well, one popular way is with metrics like the Ragus faithfulness score. What's cool about tools like this is they use another LLM to basically act as a judge. It looks at the answer and the source documents, and then it just outputs a simple score from 0 to 1. A score of 0.95, like you see here, means the answer is very well supported by the context. It's a really powerful way to monitor your system's health. Another powerful technique is natural language inference, or NLI. Here, you use a specialized model that acts as a dedicated fact checker. It compares each claim in the answer against the source text and sorts it into one of three buckets. Does the source entail the claim? Does it contradict it? Or is it neutral? For a truly grounded system, you want every single claim to fall squarely into that entailment category. Okay, we have covered a lot of ground. So to bring it all together, let's go through a final, actionable checklist you can use when you're building your own reliable, grounded RAG systems. Here's your roadmap. First, format your context with citation markers. Second, use those strong, explicit grounding prompts to control the model. Third, programmatically extract and validate every single citation and make sure you can link them back to the original source. Then automate your quality control by checking for faithfulness with metrics. And hey, for really critical answers, you should still have a person do a manual review. And finally, continuously monitor your groundedness scores to make sure your system stays reliable over time. So you've done it. Your RAG system is producing perfectly grounded, verifiable, cited answers. It's not hallucinating anymore. That's a huge win. But this leads us to the next, more advanced question. Just because an answer is factually correct and based on the source, does that actually mean it's helpful? We'll have to explore that in a future explainer. Thanks for joining me.